In this video we're going to be looking at how to use the quadratic formula in order to solve a quadratic equation. I've put the quadratic formula here, and this applies when an equation is in the form ax squared plus bx plus c. So these letters A, B and C apply to the different coefficients and C is the constant. So B is the coefficient of the x term and A is the coefficient of the x squared term. So we're going to apply that to each of these equations. I've got a few to do. They're all different types of scenarios though. If we just start with this first one, I'm going to do it quite slowly. We've got that A here is 1, B is -4, so that's A, that's B, and C is -10. So we're going to substitute those into our formula here. So x equals minus B, so that'll be -4 plus or minus square root of -4 squared minus 4 times A, which is 1, and C, which is -10. And that's all over 2 times A, which is 2 times 1. So now if we work these out, we're going to have minus times minus up here. So minus times -4 is going to be +4. So we'll have 4 plus or minus square root of -4 squared is 16. And then we'll have -4 times 1 is -4. And then -4 times -10 is +40. So this will be 16 plus 40. And that's all over 2 times 1, which is 2. So we've got x equals this. If I just do it up here now, if I simplify this square root, we're going to have 4 plus or minus root 56, and that's all over 2. So x equals that. And then we're going to have essentially two solutions. I'll simplify it a little bit more. We'll do 4 divided by 2. So x is going to be 2 plus or minus 56 over 2. I can simplify that 2 to be root 4 and then divide it all. So this will eventually turn out to be root 14. And so we get two solutions. So x equals 2 plus root 14, or x equals 2 minus root 14. And so essentially what we have are the roots of the equation. That's where it'll cross the x-axis. So if I just show you what that kind of looks like, it's going to be something like this. So 2 is the center point because it's symmetrical and it crosses the x-axis at plus root 14 and minus root 14 from 2. So if that's 2, root 14 is going to be, or 2 minus root 14 is going to be somewhere down here, plus root 14 is going to be somewhere up there, and then our curve is a positive quadratic, so it's going to look something like that. But these are the two solutions where it crosses the x-axis. Let's go back to the next one. This one's a -1. I'm not going to take it quite as slowly as the last one. So here we've got A is -2, B is +3, and C is +1. So x equals minus B, which is -3, plus or minus square root of B squared, which is 9, minus 4 times A, which is -2, so that'll be -8. We've got -8, it'll be +8 times 1, so it'll be still 8, so 9 plus 8, all over 2 times A, which is -4. So that's our formula there. If I just tidy it up a little bit, we'll have x equals -3 plus or minus square root of 17 over minus 4. And then obviously we'll take both roots, we'll do minus 3 plus root 17 and minus 3 minus root 17, divide them by minus 4, and we'll get our two solutions. So we'll have, again, this x equals minus 3 plus root 17 over minus 4, or x equals minus 3 minus root 17 over minus 4. So both of those will give us two solutions. Now, if we look at the third one, we have 4x squared plus 4x plus 1. So if I bring down that formula so you can still see it. So here we've got b is going to be 4, or minus 4. Then it's plus or minus square root of b squared, which is 16, minus 4 times a, which is 16 times 1, which is still 16. So we've got 16 minus 16, all over 2a, which is 8. So here we're going to have x equals minus 4 plus or minus the square root of 0 over 8. So here we're going to have just one root, because if you add 0 or you take away 0, you're still just going to get the same thing. So we'll have that x equals just minus 4 over 8, which is a half. So what that looks like, in the previous ones we had it touching the x-axis at two different points, but here it's a positive one and it crosses at minus a half, so it's going to just touch the x-axis at minus a half, like that. Let's move on to the next one, another different type. It's the final one where I'm going to actually use the quadratic formula. Here we've got 3x squared plus 2x plus 12. Just want to keep the formula in the screen. So we're going to have x equals minus 2, because 2 is the b term, plus or minus b squared, which is 4. Minus 4 times 3 is minus 12, times 12 is minus 144. And that's all over 2a, so 2 times 3, which is 6. And so we get x equals minus 2 plus or minus the square root of minus 140 over 6. Now, if you were to type this into your calculator, you would get a message saying math error, and that's because of this square root here. You cannot have the square root of a negative number, or you can, but it'll give you an imaginary number. So what we would say for this one is that this graph has no solutions. And so what that means is that if we were to draw it, the graph, it's a positive one, so it's going to be that way. It does not cross the x-axis, so it could look something like that. There's no crossing points with this x-axis here, and so it has no solutions. Just moving on to these last two, they're types of questions where you don't need the quadratic formula, and I just wanted to kind of bring those in, because quadratic formula is very, very useful, but when we can factorise or solve things without it, it's just much easier to not. So for this one, this first one here, 2x squared equals 0, we just have to think what value of x would give us 0. Well, x has to be 0 in this case. And in this second one, this is a type where we would factorise into a single bracket, We can factorise into double brackets and solve as well. In this one, I'm going to take out an x, and we'll be left with 3x plus 4 equals 0. So either this equals 0 or this bracket equals 0. So we'll have x equals 0 or 3x plus 4 equals 0. So 3x equals minus 4, x equals minus 4 over 3. And we've looked at solutions like this in a previous video. So the main thing to take from this is using the quadratic formula, and just be careful, you can get scenarios where there are no solutions, where there's just one solution where it just touches the axes, or where you have two solutions. So in this top one we had a positive quadratic because the x squared term was positive. Here we had a negative one. So this top one, if you remember, looked something like this, and this bottom one down here would have looked something like that.